Hello, everyone. Thank you very much for joining us today for TS4 Retrofit Design webinar. If you didn't do it already, please activate your screen sharing by going to join.me/TigoEnergy1. And if you did, thank you and be patient. We'll give a couple more minutes for people to join, and then we'll go ahead and start. In the meantime, you do have on your Join Me bar a question, a chat box. You can use that to chat me questions during the presentation. If you have them, please go ahead. It'll help me know whether you're listening or not, which will be very useful, and also to know what would you guys like to learn more about, since we're a relatively small group. All right. The last before we start, if any of you, one of you or more, can please chat me, use the chat box to say that you can hear me. That will be great. That's how I know you're ready to start. All right. So thank you everyone for joining us this afternoon in the UK, or morning of the East Coast, or early morning here on the West Coast. My name is Gal Bauer, and I head the training and development group for TIGO. I'm calling you from Los Gatos, California, which is not sunny yet, unfortunately, but hopefully it's going to be soon. Today we're going to talk about TS4 retrofit. We're going to talk about what is TS4 retrofit, what are the different application covers that are available with it, and then jump into the design guidelines. Specifically, we're going to be talking about string design and layout, what changes and with which of the covers. Then moving to selective deployment, which is a brand new feature unique to the TS4 series. If you already know the TS4 series, that shouldn't be new to you. If you don't, so it's very exciting. If nothing else, it's worth hanging tight for it. And last, for the covers that are relevant for that, we're going to talk about communication path. and basically the other accessories you'll need to design and account for when designing a TS4 retrofit system. Right. So, a brief historical overview. Most of the people still know Taigo as an optimizer company. If we look at the left-hand side of the picture, we started the company around late 2007. In 2008, we already shipped our first optimizers, or legendary maximizers, module maximizers, as a retrofit solution only. They were mounted to the panel frame, and the goal was purely to gain more energy and mitigate mismatch. Later, after we basically proved that there is a mismatch problem and optimization is probably something that's needed for solar systems, we were able to basically convince module companies that, hey, there is a problem with traditional solar systems, and how about we just make the installation a bit easier and have that already integrated and built into the junction box of the solar panel. Hence, Gen 2, the integrated, junction box with power electronics already embedded inside. With these first generations, we basically accumulated a lot of knowledge. We have systems that are operating worldwide, over 22,000 systems, and over 1.2 million units that were shipped worldwide, giving us a lot of information, a lot of knowledge about how PV modules behave, what do they do, how does it really work, how do they actually perform, which led us to Gen 3, developing the Gen 3. What's unique about Gen 3, which is the TS4 platform, is that it's modular. One of the things that Gen 1, Gen 2 taught us is that not all customers are alike. Not all customers have the same requirements, and even if the customer sees that, yes, I really value that, I may not value that specific feature for all of my projects. Hence, we decided to go for a modular approach, offering different types of products for at different price points, of course. And that's the TS4 platform. Along with that, we launched revolutionary concepts, which we'll talk about later in this presentation. One of them is selective deployment. So we have 5 different covers available as integrated. We'll talk about TS4 retrofit and which one is available for retrofit. These covers can mix and match, which can further help reducing your system cost. And also, optimization capabilities are now built on the new and improved predictive IV technology. For those of you who know our legendary impedance matching technology, so we didn't abandon that. We took everything we learned from the million point two units that we have outside. We learned how modules work, and we improved our optimization capabilities significantly. And it's basically coming to effect to you, the clients, by the fact that if all you care about is optimization, you no longer need communication accessories. And we'll talk about that as well when we talk about when do you need which type of accessories. All right. So moving on, TS4 retrofit. TS4 retrofit basically offers you anything that the integrated TS4 enables. Integrated TS4 has the exact same mechanical footprint, only on a module. With the TS4 retrofit, we're basically bringing all the new capabilities to any existing installation, any panel, whether it's already installed or going to be installed, but with a module that does not have the TS4 base yet. You're going to be able to retrofit it and work that and get all the benefits with the TS4 retrofit. So, as you can see, it has two parts basically. Maybe it's a bit hard to see, sorry. So it has two parts. One of them is the base. That's the one that hosts the covers and has the metal bracket connected to it. The base basically have nothing other than some plastics, connector cables, and the bracket to mount it. And the covers have all the different covers have all the electronics built into them, and we're going to see exactly which covers are available just in a minute. Before we move forward, I'll just say that one thing that's unique about our retrofit solutions or our add-on units as opposed to our competitors, and it's very clear here, is that there is no grounding necessary. This device is completely floating compared to the module, so nothing needs to be grounded. The only thing that's metal here and that somehow touches your array is this metal bracket, and inside it's just mounted inside a plastic jacket. All the electronics inside is completely floating. It's relative, sorry, only to the module, and therefore no grounding necessary. The easiest to actually mount and place on a panel. So the different application covers that are available. Sorry, I'm starting to hear an echo. So let me just make sure that everything is muted. Sorry guys, it'll just take a minute. Mute that. I did mute. Alright. Great, presentation mode. And now hopefully we won't have echo anymore. Perfect. So, sorry about that. Moving on, so we're talking about the different functions at different price points. With the TS4 retrofit basically offers you to take any existing installation or any new PV module that you want to install and for some reason is not coming with the TS4 base on it. Take it and enhance its capabilities. You can give it either monitoring, which will provide module level data. You can give it safety, which will have module level disconnect. Functionality is incremental, so safety will also include monitoring. So TS4 RS basically includes inside also the monitoring capabilities. And last, we have the optimization, the highest one up in that series. The TS4 RO has also safety capabilities built in and module level monitoring. And we'll talk about that. We're stuck. All right. So, a bit more in depth about the different covers. So, monitoring gives us module level monitoring. Basically, you can see with that cover power of each individual module, current and voltage. Current and voltage, of course, for the individual module. If we look at current, that'll be a good representation of your actual string current, which can be very useful for large-scale applications. Measurements are a 2 seconds increment. As customers, you'll see 1 minute data granularity, which is pretty awesome and pretty competitive with everything else that's available, and it's awfully useful for maintenance actions. Um, Imagine you can just go out to the field. Even before you go out, you just have a map, like we see here on the right hand side. Yes, it takes some time to build it with our online wizard. Um, but it'll take you to build a system like that roughly an hour if you're not experienced. And then you'll have module level data for the rest of the system life. So for 25 years, you'll see exactly what's going on with your system. So overall, I think it's worth it. Last, we do have fleet management capabilities, CRM integrations with advanced APIs, and since you know everything about the panels, what they do, what they manufacture at the exact moment, that can help you with warranty tracking and actually telling whether your panels are performing as they should or not. Safety, the next cover up, gives us, well, in the US, it gives us rapid shutdown compliance. That's the first one. It gives us rapid shutdown compliance. It has a module level disconnect. If we look at Europe, it complies with the VDE standard. I believe it's 2100 for disconnect. I believe over there it's below 120 volts. So of course, if you have module level disconnect, um, it's an overkill almost, but good to have. The module level deactivation can happen automatic or manually. Automatic when the units detect some sort of safety hazards like over voltage or over temperature. The unit itself will shut down in order to protect the system and protect the asset. In case it shuts down by itself, it will also wake up by itself, so you shouldn't worry about the modules shutting off and then staying off until you tell them otherwise. That's not going to happen. And manual, if you push our PV safe, which is our safety disconnect button, you can deactivate the system, or if you take the main AC out, like first responders do in case of an emergency. They take the AC out, both the inverter and the cloud connect, well, our data logger, basically lose the communication, and the TS4 safety and above covers basically understand that that's a safety hazard. Somebody took the AC out, so they shut down. They automatically wake up or turn back on and resume power production the minute that the AC is back on and they hear the communication again. And as I said at the beginning, the functionality of TS4 is incremental, so safety also includes all the monitoring capabilities and benefits. Next functionality up, we have the optimization for increased energy harvest to ease your design, and that will be our main topic, which we'll start talking about in just a couple of minutes. It gives us shade and age tolerance. It gives us the ability to deal with complex roofs, as you can see on the right hand side. Just to give you an idea, so Green Tech Media, which is a very reputable institute here in the U.S., they surveyed all the residential rooftops in the U.S., and they actually determined that only 24% of those are suitable for traditional solar. So only 24%, and we want, of course, solar to grow and become massive. In order to do that, one of the things we must deal with is our addressable market. A great way to increase that, deal with east-west orientations and problematic rooftops because of shading or whatnot, is to basically use optimization. Now, as I mentioned at the beginning, TS4 series and as well as TS4 Retrofit has now predictive IV technology inside its optimization covers. Predictive IV, that's basically state-of-the-art optimization technology. In a nutshell, we took all the information that we had from years of experience with optimization technologies, and now we don't need communication in order to determine whether a module is performing well or not. We can just look at the individual module and understand what is the best setting for the entire array. As far as you, if you're designing a system, what it basically means, if all you care about is optimization, you no longer need any communication accessories, which is pretty substantial and a pretty huge cost reduction. All right. So, just before we finish that part and move forward, do you think this is all? The answer is, of course, no. We also enable selective deployment. So we talked about the fact that there are 3 different covers. Imagine you have a house just like that, where you really want to have module level monitoring on everything because the homeowner really likes it, because it protects the assets, um, because gives you whatever, because for you it's a good referral to have him go around and show the monitoring app to his neighbors, and then you get referrals. So that's what you want. And then on the roof you see that there's suddenly this dormer that you didn't think about, or you didn't know that exists, or somebody promised you that it's way more shallow and doesn't shade as much. You get there and you find that you have shade on these ones. What you can do now with the TS4 series is basically optimize only these 3 panels. So instead of changing the entire design, changing the entire layout, buying optimizers for I don't know how many panels there are here, 20, 30 panels, all you need for 3 shaded panels is 3 optimizers, which is pretty unique. So yes, all of them can be mixed and matched, and here's when we'll start talking about it. What can you do, what can't you do, and all the benefits around it. So, if you didn't have any questions so far, which I think you didn't, so I'm just saying, don't be afraid. I promise I'll answer nicely to all. All right, so string design and layout. If you look at the TS4 retrofit covers, so the monitoring and safety are basically passive components as far as the string design is concerned. They don't do anything. They don't have any optimization capabilities. Monitoring only does monitoring. Safety does monitoring and module level disconnect. So both of them has in standard operation behave exactly like standard PV modules. All right. So whatever it is, your standard system design guidelines, whatever it is, your minimum or maximum number of panels per string, whether it's a south-facing roof or east and west with dual MPPT inverters, whatever it is you do with typical solar panels, this is what you should do with the TS4 RM, so TS4 retrofit monitoring, and with the TS4 RS, TS4 retrofit safety. Use the exact same design guidelines and layouts as you would with standard modules. Now, TS4 optimization, TS4 RO, gives you a lot more flexibility, and this is what we're going to talk about. So, let's start with best practices. Best practices for when utilizing optimization. Obviously, optimization gives you a lot of benefits, but we always start by saying, be reasonable. So yes, it will give you a lot of different things that we're going to talk about, like maximum difference between parallel strings of up to 25%. So if I have one string with 12 panels, I can put on the same MPPT another parallel string of 15 panels, so 25% difference, up to 15 panels, which is pretty awesome, and can definitely help you with your wiring on let's say residential rooftops, or if you have large arrays with I don't know, strings that need to go, you know, some of them, half the array can go up to 24 string, the other half will go up to 25, up to 25 panels, the other half will go up to 26 panels or 27. That'll be perfectly fine to put them all in the same combiner box and go to the same MPPT channel in the inverter if you're using bigger ones that do need parallel strings. So yes, we can do all these things. As a guideline, it's generally good to have them as equal as possible. So don't just go ahead connecting, your maximum number on one and then whatever it is leftovers on the other. Be reasonable when you do the string design. Next, generally speaking, we always recommend to go as long as possible with your string design. Of course, within the inverter limits, within the inverter's voltage limits. That's basically because what Tigo does when it optimizes, in many cases, what ends up happening is that the voltage drops a bit relative to how shaded the panel is or how much we actually need to optimize. So voltage drops just slightly, and therefore we always recommend put your string design or design your strings as long as possible to avoid situations where for some reason the voltage drops a bit too low, especially at high temperatures. For the same reason, this voltage drops a bit. If you can, plan the shade to be on the longer strings or evenly distributed amongst all strings. So again, for best practices, it's not like it's not going to work. If you have shade on the shortest string, it's probably going to work just as well. Our general design reliability philosophy for optimizers is we try to minimize the work of the optimizers. That's how they're so efficient. That's how they're so reliable. And doing that is by following these design best practices. Again, it's not like it won't be okay if you don't follow them. It's just always better to design keeping these guidelines in mind. Let's see, design your string so that the number of shorter strings exceeds the number of longer strings. So this is what we see here. Like I mentioned, when optimizers optimize, they basically reduce the voltage a bit. So if we look at the example here on the bottom right side, so we see we have one string that's a bit longer than the others. In that string, what the optimizers will do is they'll basically reduce the voltage across just slightly on each and every individual panel. If the situation was the opposite, so let's say this string here in the middle was also 3 panels longer. If that was the situation, what Tigo would have done is basically the same. It would take both these longer strings and it would reduce the voltage just slightly. So again, it's not like we cannot do it. It's just that for efficiency, reliability, longevity purposes, we're saying if you do have the option to do, to design so that you have fewer long strings, do that. If not, that's perfectly fine. The system is more than capable. The optimizers are more than capable to handle pretty much whatever you throw on them, as long, of course, as it stands in the next design guidelines that we're going to talk about. All right. So What does it give you? What can you do that's kind of crazy and you can't do with standard string design? Number one, we talked about it, is design uneven strings in parallel. So the guideline is up to 25%. Up to 25%, that's a flexible limit. So if you do your string sizing and you want to put, I don't know, one string that's a bit longer than the other and it ends up being 28% longer, that'll be fine. Okay, so that's a soft limit, we call it. It's not like at 25. If you put 12 and 15, it'll work, and if you put 12 and 16, that's it. Optimizers are doing nothing, and you're losing a lot of energy. That's not what's going to happen. So that's a guideline, again, to maintain high efficiencies, to maintain well, good reliability of the products. Next, design into shade. We'll talk about that just in a minute. We can basically extend the amount of roof that we have that's available for solar. And last, you can design on different orientations and pitches on the same string. So, design into shade. Basically, improve your real estate utilization. We're not saying that if you have a place that's shaded most of the day, put panels there because we can make it work. Yeah, we can make it work, but this panel will still not produce a lot of power. So I'm not saying put panels where it's always shaded because that doesn't make sense. I'm saying that if you do have a place that, let's say, is shaded 1 hour during the day, maybe 2 hours, maybe half of the day, but it still makes financial sense to put the panel there, you can put it, because what the optimizers will do is they'll basically prevent this module on the times it's shaded. They'll prevent this module from dragging down the performance of the rest of the modules in the string. So in a traditional system or standard PV system that has no optimization capabilities, if you have one shaded module, that's basically enough to reduce to basically damage and reduce the performance of the entire string, and in some cases of the entire array. What optimizers do is they mitigate that loss only to the specific panel. So in this case, like I mentioned before, let's say you have something that is, you have a panel that's shaded for 2 hours during the day. So you can rest assured that while this panel is shaded, the rest of the system is performing well. It's not performing as if it has a shaded panel. All the other modules are producing their maximum available energy, which basically allows us to get closer to objects and better utilize the roof or real estate that we have. Different orientations. Basically, the examples speak for themselves. Many times we're getting the question, how different can the orientations be? The answer is as different as you want. So you can do east-west, you can do south and east, south and west, whichever combination that you see fit will work. Optimizers will know how to handle the mismatch created by the different irradiance levels due to the fact that modules are sitting on different roof planes that are facing different directions. The only guideline in that regard is that you need to make sure that let's call it major orientations have enough panels to generate enough voltage to turn on the inverter, right? So if you have a system, let's look at the picture out at the top. Let's ignore this part. If we only had these ones, the panels on the top. So the panels here, the 3 panels here, if everything here is on the same string, the 3 panels here, when the sun is coming from this direction will probably not be enough to turn on the inverter very early in the morning. They'll probably not be enough. What will happen and what will be useful, and that's why probably you'd want to put panels there, is when the sun is here or when the sun is here. So all these modules turn on. All these modules produce energy. They turn on the inverter, and then these modules facing east are still able to generate electricity. So they'll be generating probably a bit less, especially as the day advances. So around noon, the sun will probably be here. Everything is really south oriented. But the panels here will be producing a bit less energy. Again, financial decisions, whether it's worth it to put them there or not. But the guideline is basically if you want an orientation to be significant enough to turn on the inverter, you need to make sure that there are enough panels there. You're right. Here's a great example of out of Switzerland, I believe, where we have this very nice rooftop in this wooden area that has 6 modules on one side and let's see, 614 on the other side. In a physical view, you can see that the upper part is what we have here on the left, and then the bottom part is what we have here on the right. And if we look at the electrical view or string view, we can see that they're all basically connected in one long string to the inverter. So again, very easy to wire, very easy to use, enables you a great deal of freedom when designing a system. All right. So far, everything I've discussed talks about what you can do with optimization. In general, all these things you could have done with, or you can still do with our legacy optimizers or with a legacy smart module, Gen 1, Gen 2. They're all capable of doing or providing you these benefits. What's unique about the TS4 retrofit, and we'll start talking about now, is the selective deployment capability. So what does it mean? We have three different types of TS4 retrofit covers. So we have the monitoring, safety, and optimization. And you probably ask yourself, okay, when do I need each and every one of those, and how do I qualify? So this is how you qualify and basically how you start your design with these modules or with these add-on TS4s. You ask yourself, do I want module level shutdown? Yes or no? Yes, no. You guys can chat me if you want me to select a specific answer. No one chats. Okay, so I'll choose yes because I'm putting it on my house and it's very important for me to know that my house is protected. Plus, maybe I get some insurance benefits because, firefighters can go ahead and shut down the system in case of an emergency, which is good. So I do want my house to be protected. In this case, the basic design, so I have 6 modules, a relatively small house. 6 modules, and I would like each and every one of them to have TS4 retrofit safety in order to enable module level disconnect. Now, moving on. Next step is I need to identify the shaded areas. I also have this very nice, let's say, apple tree. It's causing my system to lose energy, which is what you saw at the beginning. Let's do that again because it's really fun. I have this. I have my tree, and you can see that the entire production is dropping even though only 2 modules are shaded. I optimize these 2 modules, and all the non-shaded modules can basically perform at best. and this is what we see here. All the non-shaded modules perform at best, and only the shaded modules are the ones that are doing some work and making sure that they don't block the power production for the strongest ones, which happens in typical solar systems. Since I need safety, I need to be able to communicate to the panels that they need to shut down, and afterwards, I want to be able to communicate, hey, please turn on. That's why I need the communication accessories, and that's what you see here. That's the gateway and our Cloud Connect, which we'll talk about shortly. And yes, the guideline here is basically with selective deployment, you can only you can mix and match covers. And if you have a single string application like we see here, or a single string per MPPT, you can only optimize. I mean, you can optimize only the shaded areas. You don't need to optimize everything. The nice thing about it is also, okay, I optimized 2 panels, but then my tree grew 5 years later. It's very big, I don't want to cut it, or worse, it's the neighbor's tree, it grew and the neighbor won't cut it, but it's shading my system. What do? It's very simple. I add one TS4 retrofit unit, and then I get back at least some of the energy that I used to lose due to mismatch. So very cool. So if you think about how do you design with TS4, with TS4 retrofit specifically, you start with identifying the system's needs. So what does this project need? What does this customer need? Do I need to provide any type of safety capabilities? Do I want them to be able to have access to monitoring? Or whatnot. These are the type of things that you need to think about when you're designing a TS4 retrofit system, and that will easily direct you, like we saw, to which are the covers that you actually need to use. Now, selective deployment. As I mentioned, it's a single string application. So single string application meaning it's either one string going to one inverter, or in case of dual MPPT inverters, so one string going to one channel and another string going to the other channel. In this case, each and every one of those panels, I can put as many optimized covers as I want, or not at all. If I do have parallel strings, like in the case below, I cannot do selective deployment. I need to put 100% optimization or nothing at all. We mentioned before that since optimization is the TS4 retrofit optimization is equipped with the revolutionary predictive IV technology, it does not require any communication accessories. So that's still the case even if we have parallel strings. So even if I have, I don't know, 4,000 panels, they're all optimized, I do not need communication in order to have them optimizing, which is, again, very cool, new and unique compared to what we used to do up until now. So great to have in mind. If we look at the commercial applications, so we have the TS4 monitoring, and what you can do with the TS4 monitoring is basically place it wherever you want. It's a passive component. It gives you module level data, and you can use it in each and every place that you want. And the example here, the way I arrange them, of course, here I can put I have one string, which I decided to look at the entire string, and that gives me voltage and current for each individual module. The nice thing about current in a string is that it's always the same. So the current that this one will measure will be the current that this one will measure, will be the current that this one will measure, etc. And if I add up the voltages, sorry, If I add up the voltages from each individual module, I will get my string voltage. So I have string voltage coming to me from these modules. I have my string current because it's enough. And here again, I have my string current, and then my string current, and then my string current. And since they're all connected in parallel, so they have the same voltage, which is the voltage above. Hope I didn't confuse you too much. If I did, again, you're very welcome to give me questions. But that's just an example of how you can utilize selective deployment, and by strategically placing monitoring covers, for example, you can basically get string monitoring applications and different things like that. If we look at safety or optimization, the way they work is that you need to have everything with safety or everything with optimization. So like we talked about with parallel strings, you do need optimization either on everything or nothing, up to you. And safety, the same. Our safety is a module level disconnect. It doesn't break the string. So if I put one safety cover on, one panel in the string, it will not cut current for the string. It will simply disconnect one module from the string, not all the string. The rest of the string will still be producing power, voltage, current, everything. If you do want to use disconnect, you do need all the modules to be equipped with safety capabilities or with disconnect capabilities. We talked a bit before about different orientations, and what I wanted to show here is it's basically also doable with selective deployment. If we look, if we look here, so we're mentioning which orientations should have enough panels to start up the inverter. And in this case, I have my panels facing south. I have my panels facing west. And now the sun comes from here. When the sun is in the south, so I have all the panels here able to produce high power, high voltage, turn on the inverter, and then all the panels that are here are, a bit weaker because they don't get the direct sunlight, so they're effectively shade. You remember the example from the tree, wherever I have shade on a single string, so that's where I optimize. So in this example, on the top side, or on the top, we actually have 1, 2, 3, 4, 6 modules that are not shaded, and 3 modules that have a bit lower irradiance just because of the way that they're facing. These modules will need to be optimized. Next, when the sun moves here all the way to the west, these modules won't be producing much. And these panels, only 3 panels, will not have enough voltage to turn on the inverter or to keep it on. Therefore, most likely when the sun is in the west, there is no point. These ones will be more powerful than these, but they won't have enough voltage to generate to start the inverter or to keep it running. So basically, there's no point in optimizing these. All right, and if we look at the other example, so here we start exactly the same. Only when the sun comes here, I do have enough panels here, so I do have enough power to start up the inverter, enough voltage to keep the inverter running, and therefore these panels will be producing much. These panels have a bit of an angle, so they won't have as much direct sunlight, so they will be effectively shade. And again, whatever is effectively shade or effectively shade, I optimize. Again, I hope that's clear, and if not, you're more than welcome to send me questions. All right. We finished the chapter about the design guidelines as far as layout is concerned. where can you place modules, which type of covers to use and when. And now we're briefly going to cover the communication piece of it. So our TIGO system, when it communicates, has the TS4 R units. No matter how many, no matter which ones. It has a gateway. The gateway is basically an antenna. All the TS4R units are speaking or have the capability to talk wirelessly to the gateway. The gateway, the best way to think about it is like an antenna. It communicates with all the TS4 retrofit units, and then it sends the data over RS-45 cable, which is a communication cable, down to the Cloud Connect, which is our general purpose data logger. We look at the system diagram. So we have all of our modules. In this case, they're equipped with safety capabilities. So every module is connected to a TS4 retrofit safety unit. And all these units are communicating wirelessly to the gateway. Gateway is hardwired to the Cloud Connect. And then the Cloud Connect can sit wherever. Typically, it sits next to the inverter. Communicates to the internet, and then from the internet you get the monitoring interface. Predictive IV. If all you care about is optimization, if you couldn't care less about safety, if you couldn't care less about monitoring, and all you want is to put, 2 optimization units, 2, 3, 4 optimization units on the shaded areas of the roof. You don't want to deal with any other type of equipment. You want to keep costs as low as possible. That's possible. If all you care about is optimization, you don't have to put communication accessories, which is really nice. So the first thing when you design, if you decide that you do want monitoring and or safety capabilities, you will need to start with counting how many gateways you need. For gateways, each and every one of them can communicate with up to 120 smart modules. That's the first magic number you need to remember, 120. Up to 7 of those can be connected to a single Cloud Connect, and they're daisy chained, like you can see here. So they're all daisy chained, up to 7 of those to a single Cloud Connect. 7 is our second magic number. And they have since they speak wirelessly, so they do have a radius of reception, basically just like your phones. If you get too far away from the tower, the cellular tower, you lose reception. Same thing with the optimizers and the TS4 retrofit units. You need to stay within 50 feet or 15 meters from a gateway in order to have a good wireless reception. In case of metal rooftops, or if you do have a lot of metal in the area, we do recommend to keep it closer to 10 meters, simply because just like your phone gets disconnected when you go into the elevator, same thing happens when with our optimizers and gateways. And in metal environments, they don't work as well. Gateway wiring. So we talked about the fact that they can be daisy chained and they have to be linked eventually to the Cloud Connect, which is our data logger. There are 2 typical cables. One of them is RS-45 cable, just the fancy name to a 4-conductor wire, like we see here on the right side. So 4-conductor wire, that's the easiest to work with. We do have a list of recommended cables and data sheets on our resource center, which you'll all get at the end. The other common cable to use is Cat5. Cat5 cable has 8 8 little wires. Which what we recommend on doing is basically to put them all together. Well, basically put three for power, so three for power, another three for power, plus minus, and then two that will be used as your communication transfers. These cables need to be UV resistant or suitable for burial. That depends, of course, on your application. Outdoor rated, twisted pair is better for communication. Non-shielded simply because of the diameter. You need it to fit inside the cable gland of the gateway. Shielded cables tend to be a bit too thick. And as far as the as far as the conductors, that's our recommendation to keep the voltage high enough to and to have the gateways powered, working properly. If we look at the big site, the easiest way to design and the recommended is basically to draw little circles. Each circle represents 50 feet or 15 meters. Again, if you have metal rooftops or many obstacles, it's recommended to shrink it down a bit and be a bit more conservative. Be a bit more conservative. Go to 12 meters or even 10 if everything is metal. In this case, we draw our circles, we count to make sure there are no more than 120 panels in each of the circles, and then they're color coded according to which, color coded or whatever it is that's convenient for you, maybe just numbered, according to which one goes to which cloud connect. Obstacles again. Not only if you have the roof that's metal, especially if you have obstacles like HVAC units here or any other thing that's on the roof. Different rooftops will block the wireless signal. So like we see here, if I have this big obstacle and gateway here, the reception won't go all the way. Reception won't go all the way, so what you will need to do in this case is basically to add another gateway. And then you'll be able to basically have good wireless reception, have monitoring and safety properly working. For residential, it can be, I mean, it depends a lot on the roof material. In many cases, these little dormers are not actually blocking the wireless reception. However, we do recommend that in any case you'll make sure that that you have enough gateways to provide a complete coverage for the roof. And the guideline here is, of course, like before, you need to have a line of sight between gateway and each of the modules. So if I have a gateway here, it has line of sight to all of these and also for the ones over here. If I have a gateway here, this dormer here basically blocks the wireless reception for the rest of the modules and vice versa. If I look at the gateway here, again, it depends on the roof and house material and the construction material. If everything is wood, for example, most likely that won't be an issue. But nevertheless, we do recommend that you have enough gateways. So when you do designs for a gateway placement, assume every obstacle will really block the communication and not the other way around. It's easier to take gateways out and then use them in the next job rather than not thinking about it and saying, okay, it'll be fine, but then you find out that everything inside is metal or bricks or something that actually blocks the communication. That's harder. So better to extra design, and worst case, keep the gateway and use it in the next job. Again, different types of rooftops. Always assume that wireless reception will not go through the attic. You never know what it's made of. You never know the isolation material type. Um, Sometimes it's friendly for wireless reception. Sometimes it's not. So be conservative when you design. Next, we have the Cloud Connect. They can connect to they can speak with up to 360 smart modules. So with up to 360 TS4 retrofit monitoring, safety, or optimization, up to 360 of those, up to 7 gateways can be connected in series to a single Cloud Connect. And it's also being used or can be used as a general purpose data logger to collect information from inverters, from weather stations, from whichever it is, other equipment that you have. In this case, you'll see in the picture in the bottom, you can see our module level data, and then we have two inverters, one for each string. Every string is like 5 modules. One going here, the other one going to the other one. And you can see all the a lot of the different inverter parameters, power, instantaneous power, cumulative, and also voltages. The requirement for that is AC power, internet connection, and of course you need to be able to connect the gateway to it. All right. So to sum up, I know we're getting closer to the end. We're just finishing. So the magic numbers to remember: 120. Every gateway can communicate with 120 smart modules. Up to 7 gateways can be wired in series to a single Cloud Connect using an RS-485 cable, which is a 4-conductor cable. Can be a Cat5, can be just a 4-conductor cable. Each gateway has a maximum communication radius of 50 feet or 15 meters, should be line of sight. So look at your structure, make sure there are no obstacles. If there are, that's not a problem. You simply add a gateway. It's not an expensive component. And next, last with the TS4, so we talked about monitoring, safety, and optimization. Communication is only required for monitoring and safety, right? If all you care about is optimization, you don't need all of that. All you need is TS4 retrofit monitoring. If you do want to enable safety and monitoring capabilities, which I think is very recommended, but of course it depends on your project and your needs and your budget, then you need to go ahead and plan for communication, and that's that. What else does it give you? So briefly, you get all the module level data. You can get information from inverters, from weather stations, from AC meters, whatever it is that you want. Can all be connected to the Cloud Connect. You can connect external mushroom buttons. So in many jurisdictions, in order to comply with safety codes, they actually do mandate a big push button for DC disconnect. So the Cloud Connect does have an extension at the top for the little PV safe button. So that can also be used. All the information is being sent to the cloud via Wi-Fi or Ethernet. It can be commissioned through a phone. So we do have a Tigo Smart app, that's its name, which will give you the ability to configure all of this, all the internet connections and things like that can be now configured with your phone. At the end, it will give you the module level data, which again you can see from your computer, or again from the same app. You have two options. One is to install, and one is to monitor the site. Everything that I said up until now, all of these features, everything here comes free when you buy the equipment. So there's no extra charge for the software, for the monitoring, it's free. The only thing that will cost you money is to have API access, which means to tap into the Tigo Cloud and grab the data send it to a third party, or to your own internal servers or programs. That's when you'll need API access, and everything they have here on the slide. That's the only thing that's paid for as far as monitoring services. All right. So everything we talked about, I'll send you guys the presentation. Thank you very much for listening. Everything I said and much, much more can be found in our resource center at support.tigerenergy.com. A lot of different information about the benefits, about recorded courses like this one and others. Design guidelines, how to install, how to commission, some case studies, and many, many, many frequently asked questions. If you don't know where to look for what you're searching for, just go to the search bar. We also have a product selection tool. So if you're not sure about which products to use, can you do selective deployment or not, you're more than welcome to go to our design tool. It's also in the resource center. It'll help you, it'll guide you through selecting the right equipment. It'll ask you which functionality you need. Just like we did in the example before, do I need rapid shutdown? Or sorry, do I need disconnect? Do I need optimization? How many modules do I have per string? How many strings I have in parallel, etc. And that will help me determine the right bill of material. So also very helpful. At the end, 3 points to remember. So modularity, we have 3 functional covers available at different price points, which is the key here. You can choose whichever functionality meets your requirements and your budget, which is really nice. Selective deployment, you can mix and match many of those specifically for residential or single string applications. And last but not least, we now utilize the revolutionary predictive IV technology, which means if you only care about optimization, you do not have to use communication. All right, so I went 8 minutes above what I asked for. Thank you very much for your time. Thank you very much for listening. You're more than welcome to continue chatting questions. I'll be here for a few more minutes. So thank you very much and have a great afternoon or